Let's say you invited 10 people over for a party. How many possible handshakes would there be? And again, I'm going to count a handshake as if you have two people meeting each other, that would be one handshake. What we're going to do is we're going to use mathematical modeling, which means you're kind of using a picture to describe a problem.
I don't know about you guys, but I have the most awkward situations when I first shake someone's hand. And maybe it's just me. Maybe I'm just awkward.
Nah, that couldn't be it.
I'm sure everyone has experienced an awkward handshake before. Especially to all you guys. You know what I'm talking about, right? Every single group of friends has different handshakes that they use. And I can never remember which of my friends do which type of handshake. And I've had a lot of awkward handshakes in my life, but recently I just had one of the most awkward handshakes I've ever experienced before. And it basically inspired me to make this video. I created the ultimate handshake that will help you in any situation, no matter how awkward. But before we jump into that, you have to learn all the basics. The single grip, the double grip, the pound it, the fist bump, the pound it to fist bump, the pound it to fist bump to explosion, the cup, the chicken fight, handshake to hug, the handshake to snap, the high five, the high 10, the high 6, the double hit, the too much strength handshake.
So let's say you had two people. The mathematical model of that would just be a line segment. And you would say that the number of handshakes possible here is 1. Okay, so our goal is eventually to figure out for n number of people how many handshakes. So let's look at a couple more examples. Let's say you had 3 people. The mathematical model there would be 1, 2, 3 people, and there would be 3 handshakes. So 3 people, 3 handshakes. If you have 4 people, you're going to have 4 dots, which represent the 4 people at that party, and you're going to have 4 handshakes, but you're also going to have 2 more. So we've got 1, 3, a total of 6. So I'm noticing that we don't have a linear function here. We'll do one last one. If you have 5 people at a party, you're going to have 5 people, and then you're going to have 5 more handshakes for a total of 10. So a couple ways that you could do this. You could say, oh, well, these are the triangular numbers, so I know the formula. Or you could say, well, looking at my model, how can I come up with the number of handshakes? Well, the number of people, we're going to say is n. And if I am one person, how many times could I shake hands? Here I could shake hands 1 time, which is 1 less than 2. Here I could shake 2 times, which is 1 less than 3. Here I could shake 1, 2, 3 times. So I'm seeing that the number of handshakes is 1 less than the total number of people, because I can shake hands with everyone there except for myself. Just like with the diagonal problem, we're going to double count every single one of these handshakes. So I'm going to have to divide that whole term by 2. So the number of handshakes at a party is the number of people times the number of people minus 1, because you're taking yourself out of that equation, and you're going to divide it by 2 because you don't want to double count every person. Excuse me, you don't want to double count every handshake. So that's our formula for the number of handshakes with n number of people.